In this video, we're basically gonna find the power P of the generator of voltage, and we're gonna specify whether the power P is either irrogated or absorbed. So let's draw our circuit once again. So our circuit today is going to be this one. So with the resistance here, this point one I'm gonna call A, this other point I'm gonna call B. I'm an idiot because we have a resistance here, and then down here we would have another resistance, and down here we would have another resistance, and then everything is gonna be closed. So the generator of current is gonna be called J. These my resistance R1, R2, R3, and R4. And here we're gonna have a generator of voltage. So the problem is actually saying for the circuit on the left, we know that V is equal to 12 volts, J is equal to 2 amperes, and Ri is equal to I ohm. Find the power P of the generator of voltage and specify whether the power P is irrogated or not, i.e. whether it's irrogated or absorbed. Okay, so first of all, the thing here is that we have two generators, one of current and one of voltage. So I can just redraw my circuit, thinking with none of them available. So I will basically have just 2 points without anything, and down here without anything. So still A, B, R1, R2, R3, and R4. So now the idea will be later on to draw the equivalent circuit of Thevenin at AB and use it for our purposes. But for now, I'm just gonna find RTH, which is the Thevenin resistance. So RTH will be R1 plus R2 in parallel with R3 plus R4. R1 plus R2 in parallel with R3 plus R4. So if we plug numbers into this, we will get 1 plus 2 in parallel with 3 plus 4. So RTH will be 3 parallel with 7, which basically means 3 times 7 over 3 plus 7. So RTH is 21 over 10, which you can rewrite as 2.1 ohm. Okay, so now Now the thing is that I'm gonna consider this generator here, and I'm just gonna have a VTH here instead of the generator of voltage. So basically this is still gonna be my generator of current. This is gonna be my resistance. This is gonna be my other resistance. I'm gonna have plus minus VTH, and then down here I'm still gonna have a resistance and the other resistance, and they're all connected to the current generator, which is J, R1, R2, R3, R4, just like before. But I'm gonna say that I'm gonna consider the current flowing here. I'm gonna call this I1, and the current flowing here, and I'm gonna call this I2. So I1, so the current flowing here is actually gonna be given by J, okay, so the generator of current, times, well, it's gonna be given by R2 plus R4 over R1 plus R3 plus R2 plus R4. So R2 plus R4 over R1 plus R3 plus R2 plus R4. So I1 is 2 was the generator here, 2 amperes, times, well, 2 plus 4 over 1 plus 3 plus 2 plus 4. So I1 is actually 2 times 6 over 4 and 4 is 8, 9, 10. So 6 over 10. So I can those two cancel, and I get 1 here and 5 here. So I1 will be 6 over 5, which I can rewrite as 1.2 ampere. Then I2 is going to be J times R1 plus R3. Sorry, this one. Yeah, this I should really write 2 correctly. So R1 plus R3 over R2 plus R4 plus R1 plus R3. So I2 is R1 plus R3 over R2 plus R4 plus R1 plus R3. So I2 is 2 times, well, R1 is 1, R3 is 3, R2 is 2, R4 is 4, R1 is 1, R3 is 3. So I2 is 2 times 3 plus 1 is 4, 3 plus 1 is 4, 4 and 4 is 8, plus 2 is 10. So those two cancel just like before. So this becomes 1, this becomes 5. So I1 is just 4 over 5. I'm sorry, I2 is just 4 over 5, which I can also write as 0.8 amps. So now I can apply the Kirchhoff voltage law to the upper here, and I can say, yeah, I'm gonna apply the Kirchhoff voltage law to the upper part. With the upper part, that basically means this one, okay, this one. So the upper part will be VTH plus R1 times I1 minus R2 times I2 equal to 0. So VTH, which is the one we're looking for, it's gonna be given by R2 times I2 minus R1 times I1. So VTH will be 2 times I2, so 0.8, minus R1, which is 1 times 1.2. So VTH is 2 times 0.8 is 1.6, and this one is multiplied by 1 is just 1.2. So the age is equal to 1.6 minus 1.2 is just 0.4 volt. So I'm just gonna continue on the other page. Let me just, okay, just gonna continue on the other page. Now I don't have space, but I can basically now use and draw the Thevenin equivalent circuit at AB, okay, like at here. So the, whoops, no, I don't wanna get more than one piece of paper, just this piece of paper. Come on. It's recycled, by the way, in case you were wondering. But it has been whitened, but it's recycled. So the Thevenin equivalent circuit at AB is basically this one. Plus and minus VTH. Then we have resistance. Then this one is our point A. This one here is our point B. And then here we have plus B. And this, of course, is RTH. The current flowing is flowing this way and is called I. So now I can finally find the power P that the problem was asking for. So P is actually going to be given by negative V times I, but there is a problem. We don't know I, so we gotta find I first. But finding I is actually pretty simple, because VTH minus RTH times I minus V is equal to 0. So I is just VTH minus V over RTH. So if I plug numbers back into this equation, I get 0.4 minus 12 over 2.1. So I is actually negative 11.6 over 2.1. And again, I is equal to negative 5.52 amps. So now that I found I can find P. P is negative V times I. So P will be negative 12 times negative 5.52, which we have just found amperes. So P is actually 66.24 watts. And since the power is positive, it means that is irrogated. There we go. So yeah, we had to do a few more things. Yeah, when you first look at this problem, it was like, yeah, you expect it to be fairly simple, and it kind of is to a certain extent. But you had to do a few more things before getting to your final solution. So, it's always a case in which you gotta understand what you're doing and think about what you're doing. When you see something like this, you gotta honestly, in circuit analysis, it's like a matter of thinking about what you gotta do next and how you're gonna what are the tools that that you are aware of, and decide which one you're gonna use. Once you have done that and you start solving the problem, then everything is gonna play out, and everything is gonna be and go smooth till the end, hopefully. So, well, in this case it was. So yeah, as always, I hope it helps, and see you next time with another problem and another example and another solution, of course. Cheers and bye.